Hi, in this video I'm going to show you how to do t-tests of various types in SPSS. If you want to follow along, you can download this data set that you can see right here. The link to it is in the show notes. Go ahead and open that up if you want to follow along. If not, let's go ahead and get started. To do a t-test, we're going to click on Analyze. Just come down to Compare Means. And then you'll see the various types of t-tests that we have here. These four right here. One sample t-test for comparing the mean of some sample to a fixed value, a known value. Independent samples t-test to compare two groups that aren't paired up in any way. And this does the same thing when you have already, if you just have statistics already, like the mean, standard deviation, and you want to be able to just type those in as opposed to having a full data set. And then the paired samples, when we've got two measures on the same person, or you have people that pair up in some way, such as husband-wife pairs or twins or something like that. So we'll go ahead and show each example. Let's start with the one sample t-test. In this data set, I have 20 fictional Likert scale items and some other variables. Down here, this last one is the sum of those 20 items. We're going to use that as our dependent variable in all the t-tests. So I'm going to go ahead and pop it over here. And then it's really important that this test value here gets filled in. The test value is the value of the mean and the null hypothesis that I'm going to compare the sample mean to. So in this case, I'm going to compare it to the value 60. The only options here really have to do with the confidence intervals you're going to include and how to handle missing values. So here we have everything we need. We'll just go ahead and click OK. And the results will pop up. I've got the mean and standard deviation, standard error of the mean. Here I've got the t-test statistic, degrees of freedom, and my 1 and 2-sided p-values. Mean difference, confidence interval. And I've also got a Cohen's d, which is a standardized effect size right here. So I'm not going to discuss theory. I just want to see how to do it here. You can see these are the results for doing my one sample t-test. Next, I'm going to show you how to do a two sample t-test. And we can click Analyze from either here or up here. I'm going to do it from here. We're going to come down to Compare Means again, Independent Samples t-test. So in this case, I'm going to look at some scale, that same variable as my dependent variable, and I'm going to compare by my two gender groups. You see here that I have to define which groups are going to be included. So I click on there to pop it open, and here this is based on the coding. I have, for this particular case, I have a group 1 represents one of the groups that I'm going to compare, and that's males. Group 2 is the other group that I'm comparing it to. That's the females. I just have those two groups in this particular data set. If I had three groups, if there was a third gender group, then for a t-test I can only compare two groups. So I would need to pick the two that I want to include. This down here is great because it lets you include a cut point. If you're comparing it to a variable that's ordinal or interval ratio where you want values below some value to be one group and above another value be another group. For example, let's say that you have a race variable where 1 represents white, and then you have a bunch of other groups and you just want to compare white to non-white. Well, I'm going to basically compare the ones to everything else. So I could click on here and I could just put my cut point as say 1.5. So everything less than 1.5, which would be the ones that whites would be in one group, and everything above that would be in the other group. Or maybe I have some other data I want to compare group 1 and group 2 based on some other interval ratio variable. I can do the same thing, compare those who scored less than some value to those who scored above it. But I'm not going to do that here. I'm just going to use these two groups and hit continue. And I can estimate the effect size. And again, in these options, I just have options how to deal with my missing values. Either, I'm just going to include case by case. In other words, it's going to include whatever variables are appropriate to, can be included in this particular analysis, in that particular calculation, or whether it's going to exclude those without complete rows for this data. And then what confidence interval I want. So I'm going to go ahead and click OK there, click OK there, and I have my results of my independent samples t-test, which looks similar to the one for the one sample t-test, except that I have two groups. So I have means and standard deviations, standard errors for the two groups. And you see here, this is what may confuse some people. I've got two sets of results here, one saying equal variance is assumed, one saying not assumed. So the t-statistic, the standard calculations are done with the assumption that the variance of these scores for the males is the same as the variance of the scores for the females. So that's what this row, ignoring this part for the moment, this part out over represents. It gives me this t, degrees of freedom, with my 1 and 2 side p-value, the difference in the mean, standard error of that, and confidence interval of those difference in means. Now, it is possible, of course, that the standard deviation for the variances or standard deviations of the two groups are not equal. If that is the case, then it needs to do a correction to the t-test and the degrees of freedom, and those results are found here. How do you know which to use? Well, it builds right in here this Levene's test, which is a common test, an F-test for the equality of variances. So it does the actual test here. Because this is not statistically significant, I'm fine to just go ahead and assume equal variances. So if that is below 0.05 generally, then we would have evidence that maybe the variances are not equal for the males and females, and I would want to use the lower row instead. So that's just all built in here. And again, we also have the Cohen's d, which is a really common estimate of effect size that standardizes it. So apples and oranges can be compared essentially, but I'm not going to go into the theory here. Next, let's go up to analyze. And we're going to come down to compare means. The summary independent samples t-test. This is really convenient when you have already this information. You don't have the complete data, but you know the mean and standard deviation and so forth. This might happen, for example, if you're doing a textbook problem, as a student or something like that. And you would just fill in the information. Maybe I have 50 in the first group, and that was the mean with this standard deviation. And then in the other group, maybe I had 48. They don't need to be equal. And the mean was this, 4.2 with this standard deviation. And just tell it the confidence level you want. Click OK. Right, and then it's going to just pop up with those results. And you see it here under summary t-test. We've got the n, the mean, standard deviation for the two groups. So that's what I first three row columns are what I inputted, found the standard of the error and the mean from that. And I conducted the independent samples t-test both in assuming equal variances and not equal variances. Okay, both cases here. And it did this Hartley test for equal variance down below, which is similar to Levene's test, a little bit different, but it looks at, again, whether or not that assumption of equal variance is violated. And you see here that because that p-value is less than 0.05, you might argue there's evidence that the variances are not equal for the two groups, and then I should use these bottom results here instead. Either way, I'll get statistical significance for this example. All right, let's move to the next example. Analyze, compare means, paired samples t-test. All right, now this interface looks a little bit different. If your data is set up like it is most of the time, where you have the repeated measure for each person in a separate column. So maybe a pre-test is in column 2 and the post-test score is in column 3, something like that. Then in that particular case, I'm going to put the first variable here and the second variable here. So let's say I'm just going to, for the sake of the exercise here, assume I'm just comparing the mean of this first Likert scale item to the mean of the second Likert scale item. And what I'm doing there is I'm really looking to see whether the differences in all these values, the mean of those differences is 0 or not. So I'm going to go ahead and pop that there. If I click on Scale to and Pop, it puts it here. Okay. And this allows me here to do other more complicated things that aren't generally how most data sets are set up. So I'm just going to limit to showing it here. Okay, these things just leave it on this standard. That's the commonly done thing. And we have the same options there. Click OK. And if we scroll down, we find that for the difference in those values, the mean of the differences is 0.009. We've got all the information here, including my 1 and 2-sided p-values and a Cohen's d estimate right here. So that is my basic overview of doing my paired samples t-test and the various types of t-tests we can do here in SPSS.